So here are some key facts to remember about the Earth's structure in the core chemistry series. So the first thing we're going to talk about is just the general Earth structure, and this is what it looks like. So you've got your crust, your mantle, your outer core and your inner core. You've also got the atmosphere surrounding it, and your atmosphere is kept in place by something called the ozone layer. So there are some extra bits to the structure of the Earth. The Earth is almost sphere, and main layers starting with the outermost. Okay, so the crust is solid rock, relatively thin. It's got very low density compared to the rest of the Earth. The mantle has properties of a solid but can flow very slowly. Okay, outer core is made from liquid metals, nickel and iron, and then the inner core is made from solid nickel and iron. So you need to know and be able to describe each part of the Earth. Next thing then, looking at continental drift. Okay, so continental drift was a theory he proposed it by a man called Alfred Wegener. Okay, he thought that the Earth was originally one supercontinent called Pangaea, and the continents moved apart over time. Mountains formed when the edges of drifting continents collided with each other. He gave 3 pieces of evidence: the fact that the continents fit together like a jigsaw, similar pattern of rocks on both sides of the Atlantic, and there were similar fossils on both sides of the Atlantic, mainly from species that couldn't swim. So if they wouldn't have been able to swim over there, so they must have been when you were able to walk when the continent was all slotted together in one giant continent. Convection currents and in the mantle and seafloor spreading are eventually what proved this theory. So a little bit on convection currents. Convection currents are in the mantle. In the mantle, when the magma gets warm, because the core is radioactive, so the core is giving off heat, causes the mantle to warm up. When the mantle gets warmed up, the particles in the liquid, in the solid liquid, get less dense and they rise up. Okay, when they hit the top of the surface, it's quite cold up here on the crust, and then the particles cool down and they fall because they're more dense. So you've got low density, rise, and then you've got a high density, fall. Okay, this is all happening in the mantle. It's the magma in the mantle, and that's because the core gives off heat. There's your crust. Okay, these then convection currents cause the plates to move. So the movement of this convection current causes that plate to move. And then we've got 3 different types of plate boundaries that you need to know about. Okay, you've got destructive, where the plates move towards each other. Plates moving towards each other. The denser of the 2 plates, the heavier of the 2 plates is pushed underneath. Okay, so the heavier of the 2 plates is pushed underneath, and it goes into the mantle, and the magma melts it. Okay, causing earthquakes and volcanoes. So there's just an example of a volcano. Just move it over slightly. Okay, at a constructive plate boundaries then, the plate boundaries move apart, so you are constructing something. Magma rises up by here. When it cools down, it forms new igneous rock. That's the only type of rock you need to know about, igneous rock. If it happens under pressure, there could also be a volcanic eruption, but the big thing that happens here is new land formed. So the land closest to the plate boundary is a lot newer than the land further away. That would be old land. And then the final plate boundary you need to know about is conservative. This is when the plate boundaries rub against each other. They rub against each other, they generate heat via friction. Okay, and when they generate heat via friction, when the friction builds up, that causes the earthquakes. So finally, just want you to do a little knowledge check. Pause the video, have a go at the answers, and I'll provide the answers in a minute. So, describe the mantle. The mantle is a solid which has properties of a liquid, so can flow. Okay, what was the supercontinent called? Pangaea. What were Wegener's original pieces of evidence? More fossils, similar rocks, and the fact that they all fit together like a jigsaw. What causes a tectonic plate to move? Convection currents in the mantle. And then describe a constructive plate boundary. So at a constructive plate boundary, plates move apart. magma rises up, new land formed. And then a destructive plate boundary, plates move towards each other. The denser plate goes underneath and goes into the mantle and melts. So you get mountain ranges forming from this one. So because of the way the plates move towards each other, mountain ranges form. You also get volcanic eruptions. Okay, so if you got them all right, then you've obviously revised this topic really well and you can move on to the next topic. If you haven't, go back and watch the video again and then have another go at the knowledge check questions.